Have you ever had to use a platform that has really bad user experiences? As in it feels like the struggle bus was waiting from the minute you loaded the app or arrived at the website? Yeah, we've had those experiences too. Wouldn't it be great if there were documents to explain how they ended up in that situation? Architecture decision records could have captured that. In this video, we're going to explore the types of decisions that may be architecturally significant and what could have been captured. For the theme of this video, we're going to use something many of our audience can relate to, an event ticketing system. Many organizations struggle with software systems that become technical debt traps. It's not always about the code itself. Often it's about the decisions made during the architecture planning that led to that code. Today we're exploring how to make those decisions strategically. We'll be examining architectural decisions around building an event ticketing system, highlighting the consequences and the trade-offs. First, let's talk about architectural significance. The term was introduced by Michael Nygaard when considering what decisions to capture in architecture decision records. His core argument is about the scale of impact. Architecturally significant decisions aren't merely fixes or conveniences. They're investments that determine how the system evolves, how it's maintained, and ultimately whether it can handle future growth and change. The key characteristic is almost always consequence. What's the ripple effect of this choice? Before diving into specific architectural decisions, we must address the fundamental choice. Do we leverage an off-the-shelf solution, or do we build our system from the ground up? This decision carries massive architectural implications that will shape the entire project. A commercial solution like an event ticketing platform offers immediate functionality and potential faster time to market. However, it often comes with limitations, inflexible customization options, vendor lock-in, and potentially higher long-term costs. Building your own system, while more complex and time-consuming, provides complete control and allows you to tailor the architecture precisely to your needs. Let's say we're initially considering a simple off-the-shelf ticketing solution. This dictates much of the initial architectural choices. We'll likely have limited control over database schema, API design, or reporting capabilities. The architecture will be shaped by the vendor's constraints. Conversely, if we decide to build our own ticketing system, we have a blank slate, but we also take on significantly more responsibility. This foundational choice significantly impacts architectural decisions later in the process. If we select a highly customizable but still commercial solution, the bounded context would be dictated by the vendor's offering. But if we build our own, we have the freedom to define those contexts based on our specific requirements, perhaps prioritizing session scheduling flexibility or sponsor benefits management. Understanding these trade-offs up front is crucial. This initial decision becomes the bedrock of all subsequent architectural discussions. Let's move forward by examining the architectural implications of choosing a specific ticketing system, regardless of whether it's built in-house or purchased as a service. Selecting an event platform vendor is rarely just about price. It's a strategic decision regarding vendor lock-in, data ownership, and the ability to integrate with other systems. The decision to adopt a vendor like Eventbrite or Tito or Humanitix isn't about immediate convenience. It's about aligning with the roadmap and acknowledging the trade-offs. Suppose we want to build our own ticketing system. Let's examine the database decision. Choosing something like PostgreSQL with its strong ACID guarantees and relational structure signals a commitment to data integrity and complex queries. Conversely, selecting a data store such as MongoDB, which prioritizes flexibility and scale, necessitates a different approach to data consistency and potentially impacts reporting capabilities. This choice immediately affects our operational costs, our ability to add new features, and our overall system resilience. If we're building our own system, we need to consider the architectural style. Deciding between a monolithic architecture and a microservices architecture is a huge decision. For a long time, the choice was seemingly binary, monolith versus microservices. However, the modular monolith is rapidly emerging as a compelling alternative. It's not a monolith in the traditional sense. It's a deliberate organization of a single codebase into bounded contexts, mirroring microservices principles within the same deployment unit. Think of it as a strategically segmented monolith, applying the benefits of microservices so independent teams improve scalability, without the operational overhead of managing dozens of independently deployable services. It offers the simplicity of a single codebase within the flexibility of services. A poorly designed monolith, of course, still faces the same fundamental scaling challenges, but a well-structured modular monolith mitigates these risks. A key distinction is the single deployment unit. Microservices require significant operational complexity. managing deployments, monitoring, and service discovery across many services. The modular monolith keeps deployment simpler, focusing on changes within specific bounded contexts. This represents a sweet spot for teams that need microservices benefits, but don't have the resources or appetite for full microservices. The initial choice depends on factors like team size, business agility requirements, and the overall complexity of the application. We cover modular monoliths in another webinar. I'll include a link in the description. However, not all decisions need to be documented. Not all decisions are architecturally significant. While aesthetics are important, minor design changes rarely have architectural consequences. A tweak to the color scheme or font size won't fundamentally alter the system's scaling potential or its ability to handle peak traffic. Let's consider what happens when a system is built initially without fully anticipating the range of use cases. They build a simple ticketing system, perhaps focused solely on basic registration and payment. But as the event grows and the organizers identify new requirements, like managing sponsored benefits, handling last-minute speaker requests, accommodating student discounts, and dealing with complex session scheduling, the initial architecture quickly reveals its limitations. This is where architectural decisions matter. Initially, perhaps the ticketing bounded context was all they had. Now it's expanded to incorporate attendee management, sponsored benefits, session scheduling, and potentially even handling payments for special session registrations. To accommodate these new use cases, we need to document architectural changes. This might involve introducing new APIs between the bounded contexts, adding new services within the attendee management context, or even refactoring existing code to incorporate new business rules. Documenting these changes, clearly outlining the rationale behind them, the impact on other parts of the system, and the potential risks, is critical. It's not simply about adding new features. It's about strategically adapting the architecture to handle the evolving needs of the event. This is a powerful reminder that architecture isn't static. It must be flexible and responsive to the realities of the system's usage. The architectural decisions made here, the granularity of the tickets, the flexibility and access control, the ability to accommodate last-minute needs, determine whether the system will be a smooth, efficient operation or a source of frustration and inefficiency. It's not just about selling tickets, it's about managing a complex, dynamic environment. When building this ticketing system, start with a deep understanding of every stakeholder's needs and anticipate the unexpected. That's where you'll find the biggest opportunities to create a truly valuable and resilient system. Throughout this video, we've explored the importance of documenting critical architectural decisions, but simply understanding the use cases isn't enough. To truly unlock the power of strategic architecture, you need a repeatable, effective process. That's what our Documenting Decisions course provides. We'll teach you how to apply Michael Nygaard's proven template to capture significant decisions in architecture decision records. You'll be able to leverage AI to streamline the documentation process, and you'll learn how to create a dedicated architecture decision template directly within just the docs, making it accessible to your entire team. This course isn't just about filling out forms, it's about fostering a culture of strategic thinking and collaboration. Don't let your crucial architectural decisions go undocumented. Select the Nimble Pros Academy link in the description to enroll today and build better software one documented decision at a time.